Good morning, Algebra 2 CP. Hopefully you're having a great day so far. What I'd like to show you today are some special cases that can show up when solving the different types of equations that we've been working on, be it one-step, two-step, multi-step, or variables on both sides. There's two cases in particular that you have to keep a lookout for, as well as a couple other little interesting twists that can show up in these types of problems. So this will be shorter than last time, I promise. But let's get started out by just reviewing what we've done before. So in a problem like this, when we have variables on both sides, the very first thing I'd want to do is distribute. I think based on the conversations I've had with you in class, it seems like everybody has gotten pretty comfortable with that when you see the distribution to just dive right in and do that right away. So that brings me to negative 6 minus 12 is equal to, if I distribute the negative 3, I'm going to get negative 3x, then negative 3 times 3 minus 9. From there, we now run into our issue of having variables on both sides. I have x's on the left and x's on the right, which we don't want. What we do want to do is we want to get all those variables to one side of the equation so I can be in a comfortable two-step equation position. I can be in my happy place. So to make that happen, you can either add the 6x over to this side or add the 3x to eliminate it here over to this side. It's entirely up to you just to pick one of those ways because we have to pick something to move on. I'm going to add the 3x to eliminate 3x from the right side. That brings me now to negative 6x plus 3x. If you have negative 6x's and then add 3 more, you're now up to negative 3 of them. Minus 12, we didn't touch that, is equal to negative 9. Again, notice the reason we add 3x to both sides is because if we add 3x to the right to eliminate the minus 3x, we have to do the same thing to the left to preserve that equality. Now we're at our comfortable two-step equation. I'm happy with this. I can isolate the variable by first adding 12 over to the right. That brings me to negative 3x is equal to negative 9 plus 12 is 3. And lastly, divide both sides by negative 3. Don't forget to divide by the negative. Don't drop that negative there. I'm left with x is equal to negative 1. And there we go. That's how you would solve a typical equation with variables on both sides. All right. But like I said, there are a couple of interesting cases that can show up. The first of which is something that's known as a solution of all real numbers. Okay. I was informed that in middle school, potentially, you may have heard of this called infinite solutions. But now that we're stepping it up to high school, Algebra 1, we are going to refer to this as a solution of all real numbers. That's going to be our solution. It is true that there are infinitely many solutions if all real numbers is the answer, but we're going to refer to this solution type as all real numbers. Here's an example of a type of equation that would have a solution of all real numbers. Take a look at that equation. What that equation is saying is x plus 5, some number plus 5, is equal to that same number plus 5. Well, if you think about that, won't that be true for any number in the world? Any number in the whole wide world, if you add 5 to it, it will be equal to itself plus 5, right? This is true for anything. So what we want to look out for is when the left side of the equation exactly matches the right side, then we're in a case where no matter what value for x is chosen, it's going to work. If I pick 3, 3 plus 5 is 8, 3 plus 5 is 8, it works. If I pick 0, 0 plus 5 is 5, 0 plus 5 is 5. If you pick any fraction or decimal, it's going to work out, right? So we would say that this solution is all real numbers, which you can denote by writing the words all real numbers. You can also use this notation of parenthesis, negative infinity, comma, infinity, close parenthesis. That also means all real numbers. That's in set notation. Alternatively, you can use this, which is the capital R with a double vertical line on the left side. All three of those notations mean a solution of all real numbers. Doesn't matter which one you pick, okay? And just to write it down so you have it in your notes, that a solution of all real numbers occurs when both sides of the equation are identical. Okay. Solution of all real numbers occurs when both sides of the equation are identical. So, in any case, let's take a look at a couple examples where this is true. All right. Consider something like this. I have 3 times 1 plus 2x plus an additional x is equal to 3 plus 7x. All right. If we go through our usual problem-solving process here, again, we would start by distributing, just like we did in this first problem up here. Distribute the 3 to each term. This gives me 3 plus 6x, because that's 3 times 2x, plus x is equal to 3 plus 7x. Now we would combine like terms on the next step. I have 6x and 1x on the same side of the equation. Putting them together, if I have 6 x's and an additional x, I now have 7 of them. So that gives me 3 plus 7x is equal to 3 plus 7x. 3 plus 7x is equal to itself. Well, that's true no matter what value of x you use, be it an integer, fraction, decimal, whatever, irrational number, whatever you want to use. This is going to be true all of the time. If you take a number and multiply it by 7, then add 3, and you do the same exact thing, well, then you're going to get the same result twice. So you would say this has a solution of all real numbers. Again, you can denote that solution by writing this r. You can use the negative infinity to infinity, or you can say all real numbers. Either way. All right, let's take a look at another one where that occurs. This one's going to have a little interesting tidbit of information in it that we have to look out for. Ready? 4x minus 2 times 8x minus 2, all in parentheses, is equal to 4 minus 12x. Okay, take a look at that problem. At first glance, hard to tell, right? I am kind of spilling the beans to tell you that that has an infinite number of solutions because we're doing it under the section that is a solution of all real numbers. But at first, it can be a little not so clear, right? It's not like it immediately stands out that it has a solution of all real numbers. But after we go through a couple steps, you'll be able to see that start to appear. Again, we're looking for when both sides match. So the reason I picked this problem in particular is because it has this interesting little -2 thrown in there with a distribution that has to occur. When we see this happen in the middle of an equation, we treat it just like as if it were at the beginning of an equation. I need to remember to distribute the entire negative sign to the 8x and to the -2. So it's going to be -2 times 8x and -2 times -2. A common student mistake is to do one of two things. Either forget to distribute the negative and just do 2 times 8x and 2 times -2, or if this were a regular old number, like 5, a lot of students will be very tempted to combine like terms and make this 5 minus 2 is 3 and then multiply. But remember, order of operations, multiplication would come first. Okay? So that's exactly what we're going to do. We're going to distribute the -2 times 8x, -2 times -2. I get 4x minus 16x plus 4 is equal to 4 minus 12x. Okay? Once again, we have a little combining like terms that we can do on this left side here. 4 x's, take away 16 of them, leaves us with 12 x's, -12 x's rather, plus 4 is equal to 4 minus 12x. Well, by the commutative property, if you don't remember what that means we can switch things around freely. These are really the same exact thing, right? -12x plus 4 here, -12x plus 4 here. Yes, they're written in opposite orders, but they're still the same thing. If you prefer to switch those around and say -12x plus 4, be my guest. But regardless, when you notice that both sides of the equation match up, that's an indication that the solution here is, in fact, all real numbers. Any value for x would satisfy that equation. Any value for x. Okay? Cool. So that's one kind of crazy thing that can show up in these types of problems. Again, it's a kind of a rarity. It doesn't show up frequently. It's not like every problem from this point on you're going to see a solution of all real numbers. But just be aware that it is something that can occur. Okay? Now, let's move on to the second type here of weird thing that can happen. And the second weird thing that can happen is instead of a solution of all real numbers, it's quite literally the polar opposite, and it's no solution. Okay? No solution. All right? Take a look at a problem like this. Ready? If I have a good example of something with no solution would be this. Okay? Here's an example of something with no solution. X plus 3 is equal to X. What that equation is attempting to suggest is to find some number for X for which that number plus 3 will equal itself. Well, that is impossible, right? If you start to think about it, what if X was 5? Well, 5 plus 3 is 8. 8 does not equal 5. Right? If you take a number and add 3, there's no way you can have an answer that's equal to the number you started with. That just doesn't make any sense. So when you start to look at a problem like that, it becomes very clear that there is no solution. More specifically, you can identify that there is no solution if you actually tried to get all of the variables on the same side. So if I actually tried to get all of the variables on the same side, suppose that I subtracted X to say, oh, well, I have variables on both sides. Let me get all the variables on the same side, right? You would notice that all of the variables end up canceling out, and that always happens in a no solution problem, right? Here I would have the fact that I took away a factor of X means we get rid of this one. We have to do that same operation to the left side as well because it needs to preserve equality, or try to. Here, we would notice that this is going to cancel out as well, and we're left with 3 is equal to 0, but that's not a true statement, right? There's no way that that makes any sense. 3 is not equal to 0, and in case you've never seen this notation, the equal sign with a slash through it means not equal to. 3 is not equal to 0, and there's no value for X that would make this work, so we can therefore say that this has no solution. Again, you can denote no solution by either writing no solution, or you can write this. If I use a curly bracket and then write a 0 with a line through it like this, it's not really a 0, it's an O with a line through it, and then this, that means no, that's a fancy way of saying no solution. Okay, some people don't put these curly braces and just put the circle with the slash through it. That's fine as well, but technically it should look like that. All right, and so again, a solution of, or I should say, no solution, I'm going to say a solution of no solution. No solution occurs when all variables are eliminated in the solving equations process and we are left with a false statement. Okay? So no solution occurs when all variables are eliminated in the solving equation process and we're left with a false statement. Here, we saw that when I tried to simplify this little equation, all the variables were eliminated, we're left with a false statement, so no solution. One thing that's kind of interesting is back on the all real numbers solution, I did kind of leave it at the fact that, oh, it occurs when both sides of the equation are identical, which is certainly true. But think of if you subtracted x from this, or 7x from this side to try to look at this equation here and get all the variables on the same side, you would subtract 7x from this as well, and you'd be left with 3 equals 3, which is always true. So really, a solution of all real numbers occurs when you eliminate all the variables and you're left with a true statement, like 3 equals 3. And no solution occurs when you eliminate all the variables and you're left with a false statement, such as 3 equals 0. All right, let's take a look at some examples of no solution, and then we will be on our way. Okay, how about this? Good example, negative 21 plus 5x is equal to 5 times x minus 4, and then plus 3. Okay, like I said, already kind of letting the cat out of the bag that there's going to be no solution, but let's actually see that in action. What I would do here is I would start by distributing the 5, 5 times x, and 5 times negative 4. Leaves me with negative 21 plus 5x is equal to 5 times x is 5x. 5 times negative 4, negative 20, and then plus 3. It just sits on the end there. Now I can combine like terms on the right side. Notice we have these two numbers, negative 20 and positive 3, that we can squish together. So this is going to be negative 21 plus 5x is equal to 5x. And if I have negative 20 plus 3, that's going to be minus 17. Okay. Now I can go from there, and we have variables on both sides. I'd like to get all those variables on the same side. You can probably already see where this is going. In order to do that, I would try to subtract 5x to eliminate the 5x from this side and move it over here. It would combine with the other 5x, correct? Because x's combine with each other. It wouldn't combine with this. And when we do that, when we eliminate the factor of 5x from the right side, it would also get eliminated from the left, coincidentally, and we'd be left with negative 21 equals negative 17. But that's not true, right? That's never going to be true. This is not a true statement. Therefore, we would be left with no other option but to say that this equation has no solution. Again, you can indicate that with the curly braces, and it looks like that. Okay, no solution. Alrighty. Again, take a look at what you even have up here. You might even be able to tell from this step. Some number times 5 minus 17 should equal that same number times 5 minus 21. There's no way that can happen, right? You can't do that. It just doesn't make any sense. It's hard to even explain it, but like when you look at that, it's like, that doesn't make any sense. How can I multiply a number by 5 and subtract 17, and then take that same number, multiply it by 5 and subtract 21, and then expect to get the same thing? That doesn't make any sense. All right, let's take a look at one more. That's why it's this weird case. Okay, this one's going to have another one of those distributing negatives in there, so be on the lookout for that. We got 2 minus 4 times the opposite of x plus 1 is equal to 4x minus 6. Okay, take a look at this. This one is actually a little frustrating because you'll see it's so close to having a solution, but it doesn't. Let's take a look as to why. Again, remember, we have a negative in here that's being distributed. It is very tempting, and this is, I can already anticipate the mistake of people saying, ooh, 2 minus 4, negative 2, and then trying to distribute a negative 2. No, no, no. Order of operations, multiplication comes first. So we need to take this negative 4 and distribute here, distribute here. That leaves us with 2. We have negative 4 times the opposite of x. 2 negatives make positive, so plus 4x. Negative 4 times 1 minus 4 is equal to 4x minus 6. We can go forward from here and combine some like terms on this side. Notice if this were a negative 2, we'd actually have solution of all real numbers. Not the case though. Combine like terms here, I get 4x minus 2 because I have negative 4 plus 2 is negative 2 equals 4x minus 6. Already we see a conundrum occur, right? An impossibility. We can't take a number, multiply it by 4, then subtract 2, and expect to get the same answer when we take a number, multiply it by 4, and subtract 6. It's just not going to happen. But to actually see the process play itself out, I'll try to eliminate the factor of 4x from one side of the equation, just like we would if we had a variable on both sides. It would also eliminate from the other side of the equation, and we'd be left with negative 2 equals negative 6, which is obviously bad. Negative 2 does not equal negative 6. It's a false statement. We would say that this has no solution. Alrighty. So that's how you can see equations that have infinitely many solutions, or a solution of all real numbers, or no solution. A solution, just to recap, of all real numbers means that you get matching expressions on both sides of the equal sign. 3 plus 7x equals 3 plus 7x. They match identically. They're identical, so any number for x would make that true. The exact opposite is if we get no solution, then no value for x will make this true, right? So just be on the lookout for that. Again, it doesn't mean that every single problem going forward from here will either be no solution or all real numbers, but it does certainly mean that it's another thing that can show up. So watch out for it. All right. There are a couple practice problems linked to this video, so please make sure you try to get those done as well. Reach out to me if you have any questions, but other than that, I hope you have a fantastic day, and thank you for listening. Bye, everyone. Hopefully you learned something. See you later.